We're going to go through the review so that you're ready for our Module 15-16 exam. So the first thing you need to know are a lot of definitions. The first definition is the definition of a leading coefficient. The leading coefficient is the coefficient of the first term of a polynomial in standard form. So that means when you write the polynomial in standard form, the first number you see is your coefficient. If there's not a number, then the coefficient is understood to be 1. What are like terms? Like terms are terms with the same variables raised to the same power. So when you're looking at them, they have to have the exact same variables, and those variables have to have the exact same powers. The numbers do not matter, but the variables and their powers do. What is a term? A term is a single number or variable or product of numbers and variables. So when you're looking at it, you will not see any plus or minus signs. Just a single number or variable, or you're multiplying a number and variable together. That brings us to polynomial. Poly is a prefix that means what? If you said many, you would be correct. Polynomial is a monomial or the sum of monomials. So in this case, you would actually see pluses and minuses in some of them. A polynomial can be just that single term, or you can be adding many terms together to get the polynomial. So, what is a monomial? A monomial is a polynomial with only one term. Remember, the prefix mono means one. So, how do you find the degree of a monomial? You simply add the exponents that are in that monomial together. So the degree of a monomial is the sum of the exponents used in a monomial. So you just look at the exponents and add them all together, and that is your degree. And finally, what is the standard form of a polynomial? It is a polynomial in one variable written with its terms in order from the greatest to the least degree. So we start off with the term that has the largest degree, and we go clear down to the smallest degree. A lot of times the last term is simply a number because that's to the degree of 0. So you would start out with, if you had x to the 4th as your largest degree, you'd start out with x to the 4th, and you would end up with whatever number you had. So that's your definitions. Now we do the math. Mr. Brock wants to buy a tarp to cover his building. He needs to know the surface area that needs to be covered. Find the area so he knows what size to buy. So area is length times width, base times height. We're going to use base times height. Our base is 12x squared plus 7x, and our height is 2x to the 3rd. Remember, we have to distribute. Two x to the 3rd times 12x squared plus 2x to the 3rd times 7x. Two times 12 24. X to the third times x to the second, x squared. You add your exponents. 3 plus 2 is 5. 24x to the fifth. 2 times 7 is 14. X to the 3 times x to the first, x to the 1. 3 plus 1 is 4. And we are done. We don't know what the value x is, so we cannot go any further than the expressions. Use a figure to answer the following questions. Number 1, what is the perimeter of the triangle? Your perimeter is all the way around the triangle. So you're going to find the sum of all three sides. Add them up. 3a minus 2 plus 6a plus 1 plus 5a plus 3. 3a plus 6a plus 5a, those are my like terms, minus 2 plus 1 plus 3. Okay, 9. 3 plus 6 is 9, plus 5 is 14. 14a. Negative 2 plus 1 is negative 1. Negative 1 plus 3 is positive 2. So now, we're going to find an expression that represents the area of the triangle. This time, instead of adding, we're going to multiply. We're not going to use the hypotenuse, we need to use those two legs. The legs are found beside the right angle. These are your legs. That's what we're going to multiply together. 3a minus 2 times 6a plus 1. If I do the box, okay, so 3a times 6a, 18a squared. Negative 2 times 6a, negative 12a. 3a times 1, 3a. Negative 2 times 1, negative 2. Remember, when we use the box method, we have to combine at the diagonals. So we will have 18a squared, negative 12 plus 3 is negative 9a, and then minus 2. Are we done yet? No. We've still got to take this expression and divide it by 2. So our area is 18a squared minus 9a minus 2. And we divide everything by 2. So my area is the expression. 18 divided by 2 is 9, 9a squared. 9 divided by 2, and it's minus. 9 divided by 2 is 4.1, 4.5 a. 2 divided by 2 is 1. Okay, so now we've got that expression that models the area. But what if a is equal to 4? So let's do a little substitution. 9a squared minus 4.5a minus 1. 9 times 4 squared minus 4.5 times 4 minus 1. Now, to make my life easier, I'm going to put that into my calculator and hit enter so I can find the correct answer. 9 times 4 squared minus 4.5 times 4 minus 1. 125. Now, what units are we in? Well, we don't know, so we simply put u squared to let the person who reads this know that we're not sure what units we're using. Okay, the next ones will be adding, subtracting, and multiplying expressions. So if you're looking at the first one, this is simply doing the distributive property. 3x squared times 2x squared minus 3x squared times 5. 3 times 2 is 6. I've got 2 x's here. I've got 2 more x's. That gives me a total of 4 x's. Minus 3 times 5 is 15. X squared, because there's no other x's to combine it with. If we go across to D instead of going down, we've got several steps we have to do. First, we have to distribute the g squared. Then we have to distribute the negative 6. So, g squared times 5g minus g squared times 3. Okay. Negative 6 times g squared is negative 6 g squared. Negative 6 times negative 4. So I've got 2 g's here, I've got one more, so that gives me 5g to the third. This would be 1 times 5, which is where the 5 comes from. G squared times 3 is simply 3g squared. Minus 6g squared. Negative 6 times negative 4 is positive 24. Now, if that's what you left as your answer, you would get it half right. You still have to combine those middle terms. Those middle terms are both are like terms. So 5g to the third, negative 3 minus 6 more is negative 9g squared plus 24, and we are done. The next one is what we call the difference of squares. Because we've got the exact same numbers, and one time we're adding the number and the second time we're subtracting it, then we end up with that middle term dropping out. If we do the box method, it will show you what I just said. 3b plus 2 and 3b minus 2. Okay, so this actually should be a B here, not a D. So 3b times 3b. 3 times 3 is 9, b squared. 2 times 3b is positive 6b. 3b times negative 2, negative 6b. 2 times negative 2 is negative 4. As you see, that middle term becomes opposites and it will drop out. So this is 9b squared minus 4. And we're done. For the next one, it is adding and subtracting. When you subtract, it is the same as adding the opposites. So you're going to change all of those signs for that last set of parentheses. So here we go. 3h squared minus 8 doesn't change. Plus 5h plus 4 does not change. Minus h squared minus 6h plus 8. Everything in that last set of parentheses changed to its opposite. Let's put the like terms together. We've got 3h squared minus h squared. We have 5h minus 6h. And then finally we have our numbers. Plus 4 plus 8. Oh, I forgot the minus 8 there too. Minus 8 plus 4 plus 8. Okay, we are ready to combine our like terms. 3h minus 1h, 3 minus 1 is 2. So this is 2h to the second power. 5h minus 6h. 5 minus 6 is negative 1. So this is minus h. I could put the 1 there, but you don't need it. Okay, now let's look at our numbers. We got a positive 8, we got a negative 8. Those will cancel out. And we're left with plus 4, and we're done. So hopefully you were able to get that. Okay, the next one is seeing if you know what like terms are. We don't have to change any of our symbols because it's addition. But we do have to know what to add together. So here we go. 5xy, negative xy. Those are like terms. Plus xz plus 8xz minus 7yz plus 9yz. That took more room than I expected. Okay, let's make it shorter now by combining. 5 minus 1 would be 4xy. 1 plus 8 would be 9xz. Negative 7 plus 9, well, 9 minus 7 is 2, plus 2yz. And you are done. This means we're multiplying the number by itself. So you can use the box method, you can use the distributive property, whatever way makes the most sense and is best organized for you. So if I'm using the boxes, might need to make that a little bit bigger down here. We'll see how we do with it. 4f times 4f is 16 f to the second power. Yeah, I needed to make that bigger too. Negative 3 times 4f is negative 12f. 4f times negative 3 is negative 12f. Negative 3 times negative 3 is positive 9. Once again, you are combining at the diagonal. So this is 16 f squared. Negative 12f plus negative 12f is negative 24f plus 9, and we're done. Okay, next one. Write a fifth degree polynomial with a leading coefficient of negative 8 in standard form. So fifth degree means that the monomial must have a degree of 5. Standard form means it's in order from greatest to least. Coefficient, leading coefficient is negative 8. That's what we start with. Negative 8. X to the fifth power plus, what do I write from here on out? Truly doesn't matter. X squared minus 5. I could have put 2x to the third. I could have put x to the fourth. I just have to have the negative 8 x to the fifth to begin with, and then I am good. Select all the terms that can be subtracted from negative 0.75, a to the third, b to the second, c. Okay, what I know is they have to be like terms. So I have to make sure that I have these three terms. If I'm looking, a to the third, b squared, c. So that works. A squared, not a to the third, does not work. A to the third, b squared, c. I've got the same thing. I can do that. A to the third, b squared, c. Same variables, same exponents. All three of those we could have added with what we've got. Okay, for the next one. How many terms do we have? 1, 2, 3, 4, 5. What is our largest exponent? Because it's going in standard form. Our largest exponent is 4, so we start with 6m to the fourth. So we've gotten rid of our 4. Now we're going to 3 minus 8m to the third. Now m to the second minus 3m squared plus 6m plus 9. 4, 3, 2, 1, none. That's how your exponents are. So it is in standard form because your exponents are in decreasing order. It is a what? What kind of a polynomial is it? Is it a monomial? No, it's got more than one term. Is it a binomial? No, it's got more than two terms. Is it a trinomial? No, it's got more than three terms. It is none of these because it has 5 terms, which would be a quintic. A caterer is hosting a dinner. The revenue earned from the dinner can be modeled by the polynomial function r of x is equal to 45x plus $2,000. And the cost to host the dinner can be modeled by the polynomial function c evaluated at x is equal to 25x minus 0.05x squared in dollars, where x is the number of people attending the dinner. What is the function, p of x, that will model the profits in dollars from the dinner? Well, we know that your profit is what's left over after you pay your bills. That means it becomes a subtraction problem. 45x plus 2,000 minus 25x minus 0.05x squared. Okay, we have to distribute the negative sign. So this will become a negative, this will become a positive. 45x plus 2,000 minus 25x plus 0.05x squared. Okay, x squared is our largest term. 0.05x squared comes to the front, plus 45x minus 25x plus 2,000. We're almost done. We do have those like terms that we need to combine now. 45x and negative 25x. 0.05x squared plus 20x plus 2,000. 45 minus 25 is 20. So that is how you model the profit. And this would be considered P of X. Okay, list the number of terms in the following and give an example. Okay, monomial. Mono means one. An example might be x squared, or we could put x, or 5,100, or 50,100, any number. Binomial. Bi means two terms. So that could be x squared minus 1, or 3x plus 6. You've got to have one plus or one minus separating two terms. Try. Try means 3. X squared plus x plus 1. 3x squared plus 5y minus 2. You have to have three terms with addition and or subtraction. Okay, what about a quadrinomial? Quad means how many terms? Quad means 4. So x to the 5th minus 2x squared plus x minus 1 would simply be one example, but you could make others. So, which of these expressions are equivalent to 5x plus 4 quantity squared? Okay, so let's see what it is when we multiply it together. 5x times 5x is 25x squared. 4 times 5x is 20x. 5x times 4 is 20x. 4 times 4 is 16. Add at your diagonal. 25x squared plus 40x plus 16. So if you're looking at this, here's your 20x and 20x right here. So A would be equivalent. This one doesn't have any middle terms, so it will not work. This one is exactly what we've got around the outside. That is an answer. 10x squared, that's not even multiplication. So as you look at this, go through, understand what it's asking. If you have any questions, make sure you talk to me.